That's better. Door is closed, almost. So I think it's time to start. Thank you all, first of all, for being here. It's really awesome that you're all here right after the keynote. So firstly, let me introduce myself. My name is Jaap Komans. I live and work in the Netherlands. I work for Group 9. And I'm a Java developer, software architect. I've been doing Java ever since 2002, professionally since 2006. And outside work, I'm a husband, I'm a father to 2 girls, and I'm a board playing gamer. I love playing board games with friends, colleagues. But enough about me. Let's jump to the modules. Before we start diving into the subject, let's have a brief look at where we are with modules today. So first of all, tool support is pretty good. Maven supported modules from the very beginning. All IDEs have proper support for modules. I've been told that Gradle works very well with modules as well. I don't know it from personal experience, but from that perspective, we can work with modules today, and we had that possibility for the past 2 years. It's been 2 years since they were introduced already, so for that part, it's good. But then we come to another important ingredient of our day-to-day developer life, and that's frameworks and libraries. And the adoption of modules amongst frameworks and libraries, common open source libraries, is still rather low. There's some libraries that are fully modular, but that's very sparse amount. And there's some that took some actions to be compatible with modules, but most are not there, don't even have a roadmap, or don't even care. Then about us, developers, adoption amongst us, that's really very low. Just from personal experience, I've been doing this talk before, and I did a project on modules, which I will come back to later, a little more than a year ago. So I had a lot of conversations about modules with other developers, and I haven't met one outside that project that really put it into action already. So, of course, I don't know all developers, but my personal experience is the adoption is very low. And then the question is, what is holding us back? And for that, I got a nice analogy from Sander Mak. Happy to see him here in the room today. He said, well, modules are like eating your veggies. You know it's good for you, but, well, is it fun? So I did a little experiment at home. These are my kids. And as you can see, they're not rather happy. But contrary to what you might think, it's not because there's veggies on their plate. It's because there's too little veggies on their plate. Because they're like me, a little odd, but I like my veggies. I like my modules. And now you might think, why? Why do you like modules? And for that, I want to take you back a little bit in time. A little more than a year ago. I started at a new client. And that client had a big legacy application, million lines of code, 10 teams working on it, 10 years of legacy. And on the first day, they handed me a nice architecture overview. It was something like this. Not exactly, of course, but it was structured. Not my favorite type of architecture. They sort of had some legacy within the legacy that was separated out. There was a legacy framework nicely separated out in the picture. Of course, first they learned that reality was more like this. So, more modules involved and more dependencies especially. And that's to be expected when you enter such a big legacy project. But the surprise for me came after a while of working on this product. more and more, I came to realize that there were more dependencies than this. There were runtime dependencies, mostly through reflection, and they weren't nice. They were creating cyclic dependencies amongst the modules. There were actually reflective calls from the persistence layer back to the controller layer or to the service layer. And that made it very hard to maintain, and it was very unstructured. This was actually the first and only project in my career so far where I just stopped doing a simple refactoring after a week of trying to get it done. I just dropped it. It was plain impossible. And luckily, we got a blank sheet for a next step, because the client was rolling out a new platform, and our team was lucky enough to be the first team to develop an application for that platform. So it was Kubernetes-based. The only thing we inherited was a small proof of concept, Spring Boot application based on Java 8. And I realized that there was a little bit of an issue with maintaining structure and maintaining the architecture within this organization. And I thought, well, okay, we're here. We had some room to experiment. Let's see if we can pull it off to make a modular application out of this and migrate it to Java 11 and go from there. So what I'm going to show you today is loosely based on what I did for that client. But of course, I can't use the real use case, so I'm doing something that's closer to me. I'll create an application around board games. So it's a really simple application. You can enter some data of a board game. There's a REST API. You can request it. And I also want to have ratings for board games, because I'm currently the only user, it's not that exciting. So I decided to get my ratings from Board Game Geek. For those who are not into board games, Board Game Geek is the biggest website on board games, and it has information about every board game in the world. And it also happens to expose an XML API, so that's useful for me. So this is the architecture that I'm after. This is actually the module graph. So at the very bottom, you see the domain module, which has no external dependencies, just domain classes. Then there are three modules that are more boundary modules. So there's a persistence module with Spring Data Mongo. There's the REST API module with Spring MVC. And there's the Board Game Geek client, which uses JAXB and OpenVane. And of course, I want my application to be secure, so I have a security module. It's using Spring Security and JJWT for JWT tokens. And to tie it all together, there's the application module. That's a Spring Boot application, hence the title of my talk. Unfortunately, this wasn't exactly what I ended up with, because originally the project I did was with Spring Data JPA and DB2 database. But I thought, well, DB2 on a conference, that's not too good of a story, so let's use Mongo. Let's make it a little more exciting. But as it turns out, Spring Data Mongo quite heavily relies on the classic Mongo client, which has a split package issue, which is a no-go for modules. So I had to drop that. So sorry for that. It's back to Spring Data JPA. It's now Postgres. Which brings me to what are actually the challenges that we will face when migrating this application. Well, first of all, as already mentioned, there are split packages. A split package is a package with the same name being exposed by different modules. You might say, okay, that's not too big of a problem. Probably I won't run into that. But just imagine your favorite bigger framework or library that's split across multiple jars. Mostly they share a common base package. So as soon as there's classes and interfaces in that base package, you will run into trouble. So this is a very likely scenario. And the next one is even more of a challenge, are automatic modules. So a little refresher for those who forgot or haven't heard, automatic modules. An automatic module is a jar file, a classic jar file being interpreted by the JVM as a module. And it uses some rules for that. So first of all, it exports and opens all its packages. And second of all, it reads all other modules. And up until here, this is not too big of an issue. This is just the behavior we always had. So nothing unexpected here. The challenge is actually in the module name. The module name of an automatic module, by default, is derived from the file name. And again, you might say, well, that will not be too big of an issue. Well, there's some stuff stripped off from the file name. And to illustrate the size of the problem, Robert Scholte from Apache Maven Foundation did a little research for himself, and he found 3,500 possible collisions in Maven Central. Now, the top one was parent, which obviously isn't too big of an issue. But the runner-up is library, and that sounds like something I want to have in my application as a dependency. So luckily, there's a little bit of a workaround. You can include an automatic module name in the manifest file of your jar. So that makes it possible to reserve a module name for later, when you really start adopting modules. And that makes it possible to create a unique module name. And what you see in general is that people opt to use a reverse DNS like we do with packages and with Maven group IDs. So, enough of the theory. Let's get started. What did I do to migrate my application? Well, first of all, upgrade your dependencies. Of course, there's security, there's support issues that might lead you to upgrade your dependencies. But as I said, the adoption is still rather low, but it is progressing over time. So by upgrading all your dependencies to the latest versions, you might just resolve a problem that you would have with an older version. So next step, run your application with JDK 11 or higher. Again, this is a step to reduce the size of the eventual problem. And in this case, JXB was removed from JDK in 11, so I had to find myself an external dependency to fill in for that. Then step 3, compile with JDK 11 or higher. Again, reducing the size of the problem. You will probably not run into too much issues in this step. I didn't run into any, but it's good to do that before you move on with modules. Then this is an important one, and this is also a deviation from what I actually did in practice at first. So first, prepare your module structure. If your application is not yet structured as modules, this is a good time to start making that structure visible. So, for instance, make separate Maven modules out of them. In the project that I did, we didn't do this. We started out and we had one big, well, not too big, but it was one application, one Maven module. We said, well, let's make that a module first, and then we'll figure out the rest later and split it up later on. But by that, we took on all the problems with the migration at once, which brings me to step 5. Step 5 is start adding module descriptors bottom up. So start at the very bottom of your module graph. And that's what I want to show you, because yeah, this is really representing the experience I had when doing this. So let's make that a little more readable. So we see here is the structure of the application. There's application module, the board game geek client, domain, persistence, REST API, security. Just like you saw in the picture. And at the bottom of the module graph is domain. So let's start there. So new module descriptor. And I want my module name to be unique, so I do reverse DNS. And it's not really exciting module, so there's some classes in there in 2 packages. And as these are being used throughout my application, it makes sense to export both these packages. So there we go. We have our first module. Now let's see if we can make this work. Oh. Let's see if it builds. Oops. First problem already. So scrolling up here, you see a lot of stuff. Let's see if we, so it says here something about forking, surefire. Took me a little while, but apparently there's a bug in surefire in combination with modules and JUnit Jupyter. Luckily, there's a milestone version of surefire that resolves that issue. So let's go fix that. So yes, import changes. And let's run it again. Okay, cool. So it's building now. So let's see if we can also run it. Oh, it was already running, sorry. Okay, starting. Well, that looks good. So now let's give you a little tour of the application. It's really simple. First of all, I need to log in to get a token. So let's see, that's working. I got my token. Then the database is empty because I told JPA to rebuild it at every start. So I will now post a new game to the database and response, got a new game. Cool. As you see here, there's the Board Game Geek ID, which I use to get the ratings through a separate endpoint. So if I now try to do this, this is actually going through Board Game Geek, and to prove that this is correct, I have the corresponding page here open. Well, okay, maybe if I reload this. No, okay, there's a little bit of a rounding issue, but you see, I'm more accurate. Good. So we have one module. That's really nice. Now let's hop on to the next. So new module descriptor. I won't bore you with doing all that. I prepared myself a little descriptor here. Okay, I'm a little too enthusiastic there. So what you see here, again, module name, and it requires the domain module because the domain classes are in the API of this module. Then it requires Java XML bind, that's JXB. It requires vain core, vain JXB, and it exports only one package. That's a factory package where the factory class is that creates the instances that are in other packages that I don't want to expose actually. But JAXB requires some access to do deep reflection on the XML API, so I have to open this XML API package for JAXB. So let's see if it now still works. And immediately we run into a new trouble. Okay, so there's a module not found, that's too bad, and there's a whole range of these. It says the unnamed module reads package consum XML bind from both JAXB impl and JAXB core. So apparently, there's a split package issue in the current version of JAXB. This too has been resolved, but it is only a build version that's available, and that has to do with the whole Jakarta EE migration. So there's no official version of JAXB 2.4 yet. But there's a build version available in Maven Central, and it's fairly stable. So I'm using that. Let's see here. I can replace all this with just this. Okay. Now run it again. Run it again. So there we go, it started. Let's briefly prove that it all still works. So I have to log in, create myself a board game, and then this was the module for the board game geek client, so let's see if this still works. And it does. So we're good there. Now, there's of course more modules, so let's continue. Persistence. Create a new module descriptor. And here you see it again requires the domain module. It requires Java persistence, that's JPA. It requires Spring Data JPA, Spring Transaction for my transactions. And then it exports, I think it's only package. Yeah, it's only package. And also it opens the package for deep reflection. And what you see here, I didn't do that in the previous module. I specifically say here, okay, I want to open it to Hibernate and to Spring Core. Meaning that other modules are not allowed to use deep reflection on my module. So it gives me a little bit of control of who can access my stuff. Okay. Let's move on. Where are we? REST. So this is a really simple one. It requires the domain module. It only requires Spring Web as an external dependency, and then it exports its only package. Okay. Let's move on. Security. So here you see this already has a lot more dependencies, but mostly it's Spring. And what you might also notice is, as I said before, most libraries choose reverse DNS. Spring doesn't do that, but Spring has an automatic module name in all its jars. So it's really, really good that they did that, and I think Spring is one of the few that has the right to say, okay, we're just Spring. There's no competition for that. Then it also requires, JJWT, And for some reason, I also ran into embedded Tomcat that was required here. I didn't dig into the details. I just found out it required that, so I added it. Then it exports it's both of its packages, so the core of the security module and the REST API that's belonging to that. So you just have to believe me here, it still runs. I won't bother you with proving it because I want to proceed. You might say you missed one module, and that's true. But the application module is a separate step, and I will try to explain why. Because up until now, I've been cheating a little. I have module descriptors everywhere, and Maven and IntelliJ say, okay, you're using module descriptors, we're acting like these are modules. But I'm not really running on the module path yet. So the next step will be adding a module descriptor to my main jar, which will make sure that we actually run on the module path, which will cause us to run into new trouble that we didn't run into yet, because now we will run into the reflection issues. So expect a little bit of a bumpy ride. It's just one module descriptor, but it will take a lot more effort. Good, there we go. Application. This is a little bit different than the others, of course. As you see here, it requires most of the other modules. Then there's Java Instrument for bytecode instrumentation. There's Spring Boot auto configure, Spring Beans, Spring Context. Then it exports both packages. The one has the application class, and the other has the Java Spring configuration. And it also opens both of these packages to Spring Core. Spring Core does require deep reflection on that. So let's see what we get now. Oh, no, first, I forget. I want to show you this. So now, if I open my Spring configuration class, it starts complaining. It says, okay, I need JavaX persistence here for the entity manager, because right here I'm building up my entity manager and injecting it in my beans. And there's some domain classes. And now I could resolve that by adding these directly to my module descriptor. But that's not exactly what I think is right here, because it requires Java and JavaX persistence because it depends on my persistence module. And the same goes for the domain module. That's there just because my other modules require that. So I can solve that in a different manner. So let's go to my persistence. Sorry? Yeah. Don't give it away. So what I can say here is requires transitive, which says, okay, every module that requires my persistence module also requires my domain module. And the same goes for Java persistence. So this, in my opinion, is more correct. The domain module is required because it's part of my public API of this module. And the persistence, Java persistence module is required because this module depends on it. So now if I run it, hopefully we'll get some output. But that's not too much output. So it immediately bumps into an issue with a JJWT. So let me scroll to the right. And it says here, JJWT Jackson contains this package, and JJWT API also exports that. And that's a split package issue. Now this one, I tried to resolve to file a PIR to the library and help the library maintainer out. And he appeared very open to the IDE. But there were some limitations in both his time and other agenda, for instance, support for Android with Java 7 background. So there's no progress there yet. But the good news is it's just 2 classes causing this issue. So I have a little patch prepared. Hopefully. So this just adds these 2 classes and gets rid of one of the dependencies. I won't bother you with the details. So it solves that. So just an example of what you can run into by just depending on a library. So hopefully this time we get a better result. We see the Spring banner, that's good, but that's about it. Let's see what it says. Right here it says illegal access exception, module board game security does not open board game security to module Spring Core. Okay, I forgot something. So that's actually great output I get there. So even better, I can more or less copy paste that. So it was the security module. So I need to adjust a little bit, and then I know the same applies to that package, so I'll also add that. So, next chance. Okay. Different error, which is great. So we're a step further. Here I have to dig a little bit more, and here's the cause. It says class not found exception. So apparently there's something that depends on Java SQL. Okay, didn't spot that, so again here, let's add that to my descriptor then. Oh, so good. Now, that should be better, and hopefully this time it will start. Too bad. Okay, this is actually one I really skipped over. So it also requires ByteBuddy. Now, the fun thing about ByteBuddy is that's really modular, but it's still compiled with Java 8. I won't go into the details, but it uses a nice library to generate a module descriptor for Java 8. And if I now click on this, I will get that module descriptor. So that's really neat, I think. Just wanted to show that briefly. So hopefully startup errors are over now. Oh no, there's one more. No such method exception. And what you see here, there's a dynamic proxy issue with Spring for one of the constructors of one of my classes. And as it turns out, you see here Obgenesis. That's a library that allows you to construct classes without calling the constructor. So there's all dirty stuff going on down in Spring Framework, it gives me a lot of value, but it's not really neat. But there's a solution for that as well. And this is actually a module name that I really like. JDK unsupported. This really screams, you're doing something wrong here, but we allow you to do it. But it's a deliberate choice. So let's see if we now finally get it to start. And hooray, there we have it. But that's just starting the application. So let's see if it still works. First of all, log in. Okay, that's good. I got myself a token. And then do a post for a new board game. That shouldn't be too exciting. Instead, oh, oops. HTTP 4.15, unsupported media type. What did I do? That's not something I expected. And I actually got this in my project. And I thought, well, what's going on here? And it misled me a little. Or it misled me big time, because I thought, well, 4.15, I must have changed something else. There's something wrong with my code. And it really cost me 2 days. And then I realized that the answer was right in front of me. Because when we look here at the logs, there's a warning here. So, blah, 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 blah. All at the right, it says, does not open the command package to Jackson data bind. Okay. I could have seen that earlier, but as you see, sometimes you get a little bit of unexpected outcomes that will lead you astray. So luckily, I now have the solution. So let's see, it's domain. Oh, sorry for that. And again, I can more or less copy paste that. Need to adjust it a little. And the module system really gives me proper output. It's just that Spring doesn't deal with it the way I would hope it does. So let's rerun that. That's good. Now let's quickly go through this. Problem resolved, luckily. And now for the final test, does it still go? Oh, no. This is actually something, oh, I know what I did wrong, sorry. My bad. Remember that I commented something out. So that's the new JXP dependency that I added later. Was a little too quick with adding that, and I forgot it. So I owe you some proof that it works. So let's run through it again. Log in, create a board game, and now get the rating. Yes, we're there. It's all done. Our application is modular. So that's cool. But at the same time, while I was on that project, I was also very interested in Kotlin. And I thought, can I do both? Can I get both modules and Kotlin? And as it turns out, you can. Kotlin has module support since 1.3. And the way they did it is not exactly what you might initially expect, but it turns out to be really neat. Because they said, okay, the module descriptor, the module info.java, it's good as it is. So if you're doing modules with Kotlin, you will have one Java file that's your module info.java. So they kept the same thing. which also has a nice side effect, because if you want to do mixed source, like I'm about to do now, Java and Kotlin in the same project, you have one module descriptor. So let's see if we can pull that off. I have 5 minutes. I'm hopeful. So to prove you that this works, I will take the class that's at the core of almost everything here and migrate that to Kotlin. Oh, oops, that's not what I, yes. So IntelliJ is helping me out here. Oh yeah. So there's a little bit of stuff that I won't need because it misunderstood my intentions from the Java code. So I now have a nice Kotlin class. And it says, okay, Kotlin is not configured. Oh, well, then configure it for me. Java with Maven. Yeah, domain module, great. Now you see it opens the POM because it did some stuff over here. Now, unfortunately, this isn't correct because this is configuration for Kotlin only and not for mixed source, but I'm prepared for that. So this is the correct configuration. And also, another thing I want to show you is that it also did a little modification here in my module descriptor. It says now requires Kotlin standard lib. And I said in the beginning there's no external dependencies. Now you might think, okay, there's an external dependency popping in. But in the end, you also implicitly depend on Java base. And this is just the Kotlin equivalent for that. So let's go and run this. Takes a little more time because it has to compile the Kotlin stuff for the first time. But it starts. And again, to prove that it still works, I can actually stop here because it already touched the board game class, but I will go on and see if I get the rating. So everything still works. So I myself thought that was really neat. So to wrap up, I learned a couple of lessons from doing this. First of all, go bottom up. Start at the very bottom of your module graph, because that allows you to do this step by step and not take all the problems in one go. You can even spread it across sprints or iterations the way you want in that way. Second of all, test all the paths of your application on every step. As you saw during the demo, especially in step 6, when we actually started running on the module path, there's so many things that you can run into at runtime that you would not expect. So properly test everything you do during this process. And then remember, the logs have the answer. The module system actually produces proper output and throws proper exceptions with messages that you can almost copy-paste into your module descriptor. So your first gut feeling should be, look there. Like the HTTP 415 I got, it would have saved me 2 days of my time if I would have just looked at the logs first. And then finally, it still involves quite some pioneering. It's not really mature to use for all purposes. So consider for yourself, is it worth the effort for me? In this case, in this project, for me, it was definitely worth the effort. But that doesn't really mean that it is worth the effort in every next project I will start. So make the consideration yourself. I'm wrapping up. And with that, we've come at the end. You can find the code of my demo on GitHub. And if you have any questions, remarks, please find me on Twitter, find me on email, find me in the hallway after the session. I really appreciate all your feedback, so also please give feedback through the app or in person, preferably. Thank you. Hi.
Are you sticking around? Or are you...
Yeah, I'm sticking around. Just turn this thing.
Testing 1 2 1 2. on.
Okay. Hello?
Yep. Just raise this up a little bit. Go ahead and say something. Just have a
Hello.
conversation.
Hi. Testing. How are you doing? No.
And if you want, you could just turn off the belt clip. So if you want to talk and not have
Okay, where?
this switch right here.
Okay, so let's start. Welcome. My name is Ayrton Lastori. I'm the product manager for the MySQL service that we are building on OCI, Oracle Cloud Infrastructure. So this presentation is a quick overview on what is the MySQL as a service and how to get started. So let's go. The standard safe harbor. What's this service? So MySQL as a service is really the union from the MySQL Enterprise Edition and OCI. So OCI is this amazing platform with nice software and really fantastic hardware. We are the MySQL team, and we are taking advantage of it. So we are leveraging OCI capabilities to deliver the best MySQL experience for the customers. So we use MySQL Enterprise Edition, and we try to make it easy to use. So we automate almost everything we can that are the everyday activities from the human beings dealing with database. So we automate backups, high availability, and things like that. So we are in the process of build this service. So we are onboarding a few customers to test it and to give feedback, and soon we will have this general availability. So it's secure and compliant by default. It's built on top of OCI. So, and using MySQL Enterprise Edition, so we use all the advanced security features, and it's we try to make it fun, right? So, just to make sure we are on the same page, it's a managed service, and it's important to realize what are the advantages of this model, right? So, we have these user responsibilities in this model. We have, the user is responsible for the schema modeling, query optimization, and query design, also to define the data access policies. Our team, MySQL team, is responsible to automate the tasks like backup, provisioning, upgrades, patchings, and HA, high availability. So in this diagram, we can have an idea how it works, right? So from our premises as a user, we can access the service. With an OCI account, we have this user tenancy, and there we can create the cloud resources, right? We can create virtual cloud networks, we can create VMs. Our team, MySQL team, has multiple internal tenancies, and there is where the actual MySQL instance lives, right? So the end user does not see the MySQL tenancy. The user sees only his own tenancy. And in our internal tenancy, we have this internal control plane, which is accessible by the MySQL as a Service API. And the user using a web console or CLI or SDKs can access the control plane and ask the control plane to do the things, right, to make the magic happen. So accessing the control plane, for example, you can provision DB system, which is a logical grouping of MySQL instance. And then the DB system is exposed into the user tenancy, into the user tenancy in its VCN. So from the user tenancy, you can access MySQL using the standard protocol. So it will be easier to understand, to visualize from this example, right? So let's create a basic test and dev environment using this service. The architecture is simple. We will create a VCN, a virtual cloud network, we'll create a client machine, VM, in our tenancy. And then we will ask the MySQL control plane to provision DB system with a single instance. And we can access this instance and play a little bit with it. So for 4 steps, first, some prerequisites, which are the user permissions and the creation of the VCN. Then we create the DB system and the client machine, and then we play a little bit, and finally we can delete and terminate with the resource that we've created. So using the same diagram, we can see what we're doing. We're going to create this VCN and also define the policies, which are the security rules for the user that allow the user create or use the MySQL as a service. So we are going to create a compartment. As an analogy, you can think a compartment as a file system folder where you can place things, right? In this case, you can place the cloud resource. So it's a nice way to organize things in your tenancy. And then with this compartment, we can create the policies that will allow the user or our user to create the MySQL service. And finally, we create networking, a VCN, and place our VM inside of it. So this is the look and feel of the flow, right? You accessing oracle.com, you can log in to the OCI, then you enter your tenancy ID. If you don't have a tenancy, you can use a trial account, and when we have the service in general availability, you can ask to be part of it, or now you can be part of the limited availability if you want to. After the login, you see this dashboard, clicking on infrastructure, and then you have this menu, the left menu. So we are going to create a compartment called OOW19. So just go identity, compartments, and fill the fields with the compartment name and also a description. Click create compartment. Then you are able to create the policies, right? So you go in the left menu, policies, create policy, and you define the policies to allow our user to use the MySQL service in this new compartment. So we have 3 policies there, and finally create. So now we have the policies in place, we have the compartment, and we need to create a VCN. So just click networking, VCN, and you can use the default. So just click create virtual network, keep the defaults. You can select, for example, create virtual cloud network plus related resource. So it will automatically define a network with 3 subnets, and it will create a virtual cloud network, and for each availability domain, it will create a subnet. So for those that doesn't know OCI, we have this concept of availability domain, which are, you can think this as a data center, a physical data center. So each region, in our case, we are using Virginia, has a physical data center. So we have 3 data centers, close one of them, but independent. And for what we are doing, we are creating a logical network, a logical subnet for each of these availability domains, right? So here is just, we are just listing the configurations, confirming, and hit create. So the VCN is created. If we scroll down the page, we will see the 3 subnets, and we are going to use one of them to place our endpoint of the MySQL service, and also our client VM. We are going to create a client VM to access the service. So let's do that. What we're doing is creating the DB system. So actually, we are using the web console, but we are hitting the internal control plane, and the control plane will provision the DB system, which is a logical grouping of MySQL instances, right? And it will expose a single endpoint into our new VCN. So selecting MySQL DB systems, you click Create MySQL DB system, provide a name, the description, select the subnet where you want to place your endpoint, your MySQL endpoint. This is your own subnet, right? And here you can choose between which AD you are using, you are placing your endpoint. Also, you can choose the shape, which is the compute shape, right? The size of the machine that will host your MySQL instance. So you can choose between several shapes. In this case, we're choosing the AMD EPYC processor with 15 gig of RAM, and we are going to choose the full MySQL configuration. We are going to see more about that later, but it's all about the MySQL configurations that we can customize. And also the data storage size. In our case, we are just choosing 50 gigas. So there's this nice validation of the fields. The admin user will be our MySQL root user. It's not actually a real MySQL root. It's an administrator, but we have a few restrictions on what this user can do, just to not mess the whole system, right? So we choose then the networking and hit the Create MySQL. So what's happening is the control plane is provisioning the MySQL system for you, the DB system for you, and after some minutes, it's done. You will see the new DB system, and inside the DB system, you have a MySQL instance, right? In our case, it's simple because it's only a single instance, but we can have multiple, right? If I click this instance, I see the details, I see its IP, and I see the network that it's placed, so that we can use to access it. Now we just create a client VM, right? This VM you can use to install your tools or your application, but we are going to install MySQL shell to play a little bit with it. So it's the common OCI flow. Just create compute instance, create instance, and you can select the operating system and go forward, select networking, add SSH key that you are going to use to access this VM from your workstation, right? So it's a matter of you can generate the key just with a single command, right? In a workstation, you just run SSH keygen and upload the public key file here, and here you go. So now the compute is being created. The client machine is being created. You see the IP, and finally it's running. And now you can access this client VM using SSH. So now we are able to connect to MySQL, right? We have a DB system, an endpoint for MySQL, and now we have this VM where which we can use to connect to this endpoint. So we just need to connect to this client machine using SSH from our workstation. And I'm going to install MySQL shell, just a client to connect to MySQL. It's very easy. Just go to mysql.com. You get the link and install the repository, and you install MySQL shell, and here you go. So one last step that we are missing is just to configure the network to allow the traffic of the port 3306 between the machines. So we are just opening the ports for the internal client machine to talk to the endpoint of MySQL. So we need to go to the VCN and add an ingress rule in the security list. So just click security lists and add the ingress rule. It's a generic rule. In our case, we are just allowing traffic to the port 3306, and you will see the rule there in the list. So now it's just a matter to use the MySQL shell, MySQL SH, the user that we've informed while we were creating the DB system, and the endpoint, which is the IP that we saw from the DB system, which is our endpoint for the MySQL, right? If I connect and make a select version, I can see it's running MySQL 8 and special edition for the cloud. So, and now we can start to play with this environment. So we can upload some data and make a backup, a restore, and mess with the data and recover the data. So here I'm just downloading the Sakila dataset, which is a sample database from mysql.com again. So download the tar file, untar it, and using your client machine, you can do this easily. And just with MySQL shell, just do source and first the schema file, which will create the database and the schema, and then the data itself. So you can see show database, show tables, you see it created, and then you, after do a source Sakila data, and the data is uploaded, you can select the table and see the data there, and you can start to develop your application, mess with the data, and so on. So, but before to do that, it's a good idea to make a backup. Then we can use the same initial data, and we don't need to do anything else. So to make a backup, it's just using the console. We are asking the control plane to create this backup, and then we can recover from this backup. So again, MySQL, you can access your DB system and ask to create the backup from there. So access the DB system we've created. And then if you scroll down the page, you have this backups menu on the left. And you can just click on the create MySQL backup. So the backup will be, you need to inform some backup name. There are some default names. Actually, you don't need to do too many things here. You can define if it's a full backup, incremental backup. You can define the retention period, and finally create backup. So the backup is creating. It's very quick, right? It's basically a snapshot of the file system. So it's really quick to do that using the OCI block storage. So after the backup is created, you can list your backups from the menu MySQL backups. You can, from the list of backups, you can also, from your DB system, you can access its backups. Now it's listed there under your DB system. So you have two ways to access the backups, from the backups menu and from its original instance. And now we can restore a backup. So in this case, we are restoring in another AD. And by restoring the backup, actually, we are making a clone from the original instance. So we are going to have two running parallel instances. We will keep the old instance and create another one based on the backup of the first instance. So we will just click on the backup, clone from, and define the configurations for this new instance. And we can change things like, in our case, we are changing the availability domain. So we will have DB system AD2, and now a new DB system in AD3. And here it goes. Just make sure we select the right subnet and clone from, so it creates the new instance. So now we have two instances running parallel, two DB systems and two instances, one of each. And if you click on the details, you see it has a new IP, a new endpoint, and also it's placed in another data center, in another AD. And you can connect normally and check if the data is there and if it's everything okay. Right, so another thing that we do with this is the configuration management. You can set some configurations for MySQL. For the DBAs, for MySQL DBAs here, it's just a nice way to manage your myCNF file, right? So you do this using the control plane, right? Using the service. So we have a lot of default configurations, one for each shape. So we try to optimize the configuration for each shape that we have available. And you can customize that. So you can click one of these configurations and you can change it, you can copy it, and you can change the MySQL configuration parameters, like the MySQL variables. Some of them will be read-only. You can see it here, but some of them you can actually modify. We have this versioning of the configuration. So for each DB system, you can have multiple configurations associated, and always one active, and you can have the history of the configurations. And this is useful if you are turning your database, you are changing some configurations. You can have this history, what I had in the past and what is configured now. So, and you have all the tracking of this. And you have these revisions, right? Each configuration can have a revision, a version, and you can keep track of that. So finally, after you use this environment, you can terminate, you can delete the instance. It's simple. Again, using the service, you access the DB system. Actually, you have multiple actions that you can do with the DB system, like start, stop, restart. So if you stop your DB system, we stop the billing, and you pay only for the running instance or for the compute that you are using. But here you can delete the DB system from this action menu, or from the right, you have the actions there also, and you can click delete, there's a hard confirmation here to make sure you're doing the right thing. So you need to enter the DB system name and click finally hit delete, and we delete the resource for you and free you from the bill. So you can keep the history of the deleted instance, so you can return and see the metadata for some time. So, and if you click the instance, you see what you've done. So common questions that we've been receiving: HA and elasticity, what we do and what we can do. As I said, this service is under development. We are working on this right now. And you can scale up the instance, you can scale down the instance, meaning that you can change the compute shape, you can change the storage size, and also if there's any problem with an availability domain, we detect this failure and switch over or fail over automatically. So we have this detection, this mechanism for detection failure, and handle the failover for you. So in the version we have available for the limited availability, we still don't have it, but this is something that we are working on and will be part of the product soon. The nice thing here is when you create an instance, you can select HA enabled. It's just a checkbox, and it will place redundant instance on different physical locations for you. So it's really easy, and it will be kept under the same DB system with a single endpoint. So you don't need to do anything to fail over. We do the job for you. So. Also, monitoring, a common question: how do I monitor this? You can use your external monitoring tool. You can access the MySQL performance schema. But also, we are part of the OCI platform, and we are integrated with the basic service in the platform. So OCI has the monitoring service, and we are pushing our metrics there, and you can check the basic metrics, at least from the consolidated platform monitoring dashboard. So here is just an example from the compute service. You can see the graphs, the CPU utilization. You can set up alarms. So when you create an alarm, you can receive notifications by email, for example. And it's nice because it's integrated with the whole platform. It's the same infrastructure for other services as well, like compute, right? So it's the same look and feel and the same experience. And this is something really important for us, right? To provide an unified experience across the OCI platform. We are OCI native service, so we have the same experience for the console. As you saw, to create a MySQL DB system is almost like creating a compute instance, right? We have the integration with monitoring, notification, logging, events, and audit. Events are nice because they, for example, in a case of a failover, it will generate a cloud event, and you can use that as an automation for other things, right? So even if you have a single instance, you can, for example, create an event that when that instance is stopped, it will create a new instance from backup, for example, right? Just also, the cost tracking is the same, centralized identity, search, tags, all this basic platform service are part of MySQL as a service too. And one nice thing is the DevOps tooling that we have in OCI, right? So with this platform, we can enable what people are calling the new stack, right? So we can, in OCI, you have a managed Kubernetes, you have functions for serverless applications. And using cloud events, you can integrate these things to work together. You can build a really modern pipeline using the platform and take advantage of MySQL as a service as well. So you can use it as a traditional pipeline, right, where you have virtual servers and you deploy things using your own application. But with OCI, you have, for example, Terraform as a service, resource management. And we provide, for MySQL as a service, we provide the CLI, we provide the SDK, Terraform provider that is available for other services as well. So from the DevOps perspective, it's really a nice experience because you have a lot of tools and they are all integrated. So you can extend the automation as you want to, right? So again, it's really powerful when it's combined with the cloud-native OCI service. So it's just an example of the CLI. It's the same CLI for other OCI service. In our case, you use MySQL, DB system, create, and you can use a JSON file with the configurations that you want for that new DB system and create this from the command line. So you don't need to use the web console. So it's a common pattern, right? You explore the service using the web console, and then you automate using Terraform or CLI or SDKs. So just to summarize, these are some differentiators. We are building these. We are the MySQL team, and we are building these on top of OCI, right? OCI platform. We are really happy to have this opportunity to use this platform to provide the best MySQL experience of the market. So as the MySQL experts, we are sure that we are going to make this happen, and we will have happy customers. So we are the only vendor that can have the most up-to-date MySQL version, because we build MySQL, we create MySQL, we maintain MySQL, and we can sync the version of the MySQL with the service. We also offer, as part of the service, the support from the experts. So it's a nice differentiator. And it's based on MySQL Enterprise Edition, which is our commercial edition, and has more advanced features for security, and it's all there. It's part of the same service, right? Also, as part of the service, there is a nice thing, which is the MySQL Analytics. For those that were in the keynote, we've talked about it. There are other sessions talking about it, but it's a new engine for the MySQL where you have a cluster to process your analytics workloads really, really fast. So if you haven't seen it yet, take a look. If you don't know where to find it, just let me know. I'll help you with that. And we are really excited with this, right? We can, by providing this service, we can be closer to the end user, and we can also improve MySQL, even the on-prem version of MySQL. So as I said, it's currently in limited availability. You can ask if you want to be part of the testing. At this point, we're looking more for testers that are willing to use this as a test and dev environment. So we want to make sure we have nice APIs, we have a nice experience for the developers. So you can just drop me an email. My email is ayrton.lasor@oracle.com. And we can talk. And thank you very much. So do you have questions? I think we have a few minutes. Yep, at least 90 minutes. Any question?
You set up a rule for 3306. Can we use the X protocol in 3360?
Yeah, the question is, let me just repeat the question. If the X protocol is available in the service too in another port, yes, we have this in our roadmap. For this version, we still don't have it, but it will be part of the service soon. Yes, yes. This is the MySQL InnoDB, yes. Yes, MySQL server based on InnoDB, yeah. Yeah, it's not NDB cluster, which would be great, right?
So it is, what is it? You say it's in NDB. Is it like group replication based, or is it kind of classic replication based? Is it something else based?
Yeah, for the HA, under the covers, we are using semi-sync replication in this version. We have plans to use group replication in another version when we are going to explore the local disks and VME based. But for now, we are using shared disks, and we are just using semi-sync to be able to have just 2 replicas and simple failover.
So is it going to be next year when you're going to show us how this is 10 times better than it was on Aurora?
About performance benchmarks, yeah, we 10 times better than Aurora, maybe. Yeah. Well, yeah, we are running internal benchmarks. We are confident that we will have decent performance better than RDS at the beginning, for sure. I still don't have the public numbers yet because we are making some tests and making sure that we have really good defaults, but we will come with some benchmarks, yeah. Probably next year you hear more from these numbers. But again, it's in limited availability, we want to hear from you, so it would be nice. So, and there's this new class of processors, right? Epic, AMD Epic, which is a new platform for MySQL in general, and they are available here. So we want to see how the workloads run there, and the price per performance ratio is really amazing. So we are confident this will be really good for the customers. Any other question? Okay. So again, thank you very much. If you have some interest, want to test it, let me know. My email is there. We can talk. Thank you very much.